Sir, shall we start, sir? Anand, sir?
Yeah, yes, sir. We'll start, sir. Shall I share the screen?
Yeah, okay, sir. Please start.
Sir, can you allow me to share the screen? Yeah. Whether the screen is visible, sir?
Yes, sir.
Fine. Okay, I'll start the session. Fine. Okay, so very good morning to one and all. So welcome back to the second day of the second day of my session actually. So yesterday we have started with the deep learning, and then we have seen the different applications of deep learning, and then we have seen the algorithm, the important algorithm of deep learning, the sequence modeling. We have seen that how to handle the different architecture to handle the sequence data. So we have seen that. We have seen the design patterns and what is a recurrent network and what is a recursive network, and bidirectional LSTM we have seen yesterday. Fine. So now today, so the first session, what I'm going to talk about transfer learning for natural language processing. So first, I'm going to maybe very few. A few people may be not aware of natural language processing. So I just introduce first, spend some time to introduce what is natural language processing and some of the applications of the natural language processing where we can use NLP. Then we'll move to the transfer learning concept. So the transfer learning is actually it's a one type of deep learning model. So we'll see that the term itself says that transfer learning. So we are transferring the learning. So you are transferring the knowledge. So you are transferring the knowledge from one system to other system. You're going to transfer your model. So whatever model you have already trained, so that model you are going to use for some other purpose. So the model, whatever you are trained for one language, you are going to use for other language. So that is the main concept of transfer learning. So the transfer learning was already successful in computer vision tasks. So the people working in computer vision and image processing, they are aware that. So most of the current computer vision applications, after pre-processing, they depending on the transfer learning concept. They're depending on the pre-trained vectors, pre-trained matrix we used to call as a VGG 15 is there, VG16 is there, like ImageNet, ResNet, that kind of thing. These are all the trained model, pre-trained models. So whatever, irrespective of your applications, if you want to go any computer vision task, so you can make use of that model to get some initial representation, then you can proceed with your application. That's a focus on the transfer learning. The same thing here, the transfer learning is not much studied in the area of natural language processing. So that is the reason why I have taken this one, actually, the transfer learning for NLP. We'll see to it. And after that afternoon, I'll just take some demo for NLP actually. So what are the NLP applications are available? And I'll give some examples, and then I'll run some demos. Finally, I'll explain the coding with respect to deep learning models. I'll take RNN or I'll take the CNN, and I'll take one NLP application, and then I'll explain you how to solve it and everything. Fine. So now moving to the topic. So as I said yesterday, like the same thing, I want the session to be more interactive. And please, whenever if you're having any doubt, please feel free to stop me at any time, and you can post your queries in a chat box. Fine. This is the outline of today's presentation. Already I have given a detailed outline. So first I'll start with the introduction to NLP. So this ADLML we have seen already yesterday. So that part I am managing with the NLP application. So I'm not talking about, again, I'm not going to talk about ADLML. So I'm going to talk about applications of NLP, where you can apply NLP models. Then we will move to the transfer learning concept for NLP, why we require transfer learning, the motivation of the transfer learning. And we'll see some of the techniques in the transfer learning called word embeddings, BERT, and then advanced BERT models. Fine. So first NLP, the basics. So maybe most of you people are aware about the domain, natural language processing. So when the artificial intelligence is popular, now the recently now the NLP also have its own boom. So most of the people started working on text processing and then natural language processing. The reason is actually one is the AI algorithms. We have a good number of deep learning as well as the AI models to build that. And other thing is actually a huge amount of data set, huge amount of unstructured as well as structured text data is available in internet. So if you want to extract some useful information, or if you want to develop some model out of it, then you definitely you need to process the text, or you need to analyze the text in a different way. Fine. So this is the motivation of the natural language processing. So when you say natural language, when you say the definition of the natural language, so the language what we are, what human spoken, so there is a natural language, say English, Telugu, Kannada, Tamil. So this we can say it's a natural language. So these languages are opposed to the artificial languages. So you just to see that the artificial languages. So we know that human invented artificial languages. We only invented C++, Java, Python, the languages we have invented. And we are asking, or I can say that we are forcing humans to learn programming languages. So as I said yesterday, doctors are learning programming languages. Why he should learn a programming language? The question is, so he want to develop some application. He want to interact with the computers. So the interaction in two ways. One is in the interface level. Interface level is like how you are using mobile. So without knowing anything, without knowing a single line of Android coding, a person can operate a mobile. So that is the interface level. So you can just be, whatever the applications are there built on top of Android. So you can open, or you can make use of that. You can, but you can use that app, but you cannot build the app. If you want to build the app, that is other development level. If you want to build the app, definitely you should have proficiency in some other languages, say for starting with Android or any language. So this is the case. So if you want to develop a software, or if you want to develop something, and definitely you require programming, or if you want to solve something, so you require programming. So that is the thing. So what we are doing now, so we are asking the students or others to learn the programming languages. If you want to develop something, if you want to, so first you learn this program. If you want to do something in a deep learning, then learn this Python program. So the programming plays a major role here actually. So when the interaction comes, fine. So you just think a classroom environment where you are a teacher is standing, and then a teacher is explaining programming to the students. So this is what we are doing now. So we are teaching artificial languages to students or other people. Fine. What the agenda of, what the objective of natural language processing? So when you say natural language processing, the main important thing in the natural language processing is, so as I said that, assumption I said that in a classroom environment, teacher is teaching and students are listening the programming languages. You just should think in a different way. So you are a teacher is teaching program, instead of program language, teacher is teaching natural language. Instead of students, there are computers. So computers are sitting, and then computers are listening how to the natural language. So this is called, this is the agenda of natural language processing. So rather than teaching humans, so why don't we teach machine our language? Why should we teach a programming languages to human? Instead of that, I can teach natural languages to computers. So that is a research direction of natural language processing. So NLP, as I said, that NLP is comes under the AI. So there are allied areas like computational linguistics is there, as well as the human-computer interaction. So when you say natural language processing, so we can define two different goals of natural language processing. One, I can say that ultimate goal. Another one, I can say that a short-term goal or immediate goal. Here I have a question. to you guys. So I explained what is meant by natural language. I hope it's clear. What is meant by natural language processing research. Can you tell me any of the softwares related to natural language processing you come across in day-to-day life? Quick answers in a chat box. So again, I'm repeating the question. Can you say any softwares, any NLP softwares you are using in your day-to-day life? I hope my question is clear. Fine. So I need a quick response from participants. Any software in your day-to-day life? Any answers? Keyboard master to the test typing skills. Okay. Google Translator. Exactly correct, Joshua. So Pawan Kumar said that keyboard master for the test of typing skills. Okay, fine. So that is also one of the new application. So it's a reading, whether you are typing the things correctly or not. Google Translator, fine. So translating languages, one language to other language. Google search engine. Definitely Google search engine and Alexa. Yeah, Alexa is one of the new application, but it's a speech-based application. And the email communication. So whatever you are, so we are thinking that the whatever mail I am drafting, so no one is reading that mail. So I'm drafting the mail to you, suppose. So so no one is reading that. No, I mean, definitely no person will read that mail. Only you and me only we can read that mail. But a software can read that mail. A software can analyze that. Suppose you may come across this example in a Google. Just to take a Gmail, and then you just send a message. I have attached the file and send to anyone. Don't attach anything. Just send. The system warn you. You mentioned that you have attached something and you haven't attached. See that. So a machine or a software, a piece of software is reading your text, reading your email. So that is important. So we are thinking that it's right now it's reading only that I have attached the term I have attached. So it will be it can be extended to anything. So if I'm sending some secret mails to you, definitely it will be read by a software. So that is the reason in tops in the official communication, mostly the government official communication, they won't use Gmail or that other third-party email system. So because any software can read your messages and enter, and it may be for if you are sending some messages related to ISIS. I'm saying the example actually. So the message is not only the message as well as you are monitored, because you are used to the term. You are used to the term related to terrorism or something. So your account or your where you are, and then your activity should be monitored automatically. So that's the one thing I want to say here. So that is also software, NLP software. So what we are having is actually the Google, the Gmail, email also it's a software. Now Gmail, we have a facility for auto replay, or it's giving their suggestion. So if you are typing dear, it will say that whether you want to send to Kumar, or it will automatically say that based on your first name. To address, if you add something, and then if you add someone into address and you just type dear, the whom you added the to address, no, his name will come after dear automatically. So it will suggest. So and then auto correction, yeah, correct. Auto correction, grammar correction is there as well as the spelling correction. So MS Word also we can say that it's a kind of NLP application now. It's not only the Word editor. Fine. So you're aware about the NLP applications. Great. Fine. So the ultimate goal of natural language processing is actually to build a computer system to perform like a human. Just to think how your mother hearing you, how your kid is not hearing. So like that, you are going to build a computer system to like a humans. So that is our ultimate goal. So that is what, as I said, that it's associated with artificial intelligence. NLP is the brain of artificial intelligence. So the intelligence term, in artificial intelligence, so you can see here that two things here, artificial and intelligence. So both are, it's look like contradictory, but that the intelligence term, if you want to give intelligence, if you want to develop any intelligent system, definitely you want a machine learning or deep learning models. If you want to give intelligence with respect to the understanding, language understanding, or text understanding, image understanding, you require NLP skill, NLP model in that. Okay, that is our ultimate goal. So anyway, we have a long time to go. Our immediate goal, you can say that short-term goal, what I can achieve now, what I can achieve immediately. So what you can achieve immediately is you can process the text or speech in an intelligent way. So as I said that the intelligence, so you can process the text or speech in an intelligent way. So that is if you're developing any piece of software to process the text. Suppose you are creating a software to understanding the text. Whatever I'm speaking, you want to convert that into a text. That's an NLP application. So that piece of software, they can say that it's NLP software. That is our immediate goal. What we can do now is we can build a small software to make a software to understand our whatever we are conveying, to understand that in an intelligent way. It enables human machine communication. See that how NLP enables human machine communication and how it improves human communication. Next question. Participants, how NLP techniques or NLP softwares enable human machine communication, how it will improve human communication. Any answers? Just a guess and take the problem. How it's fine. No. So how it's enable human machine communication. So the Alexa is the example. So human machine communication. Yeah, you are talking to the machine, it enabling that. Human communication, how it's improving human communication. I can talk to a person who knows only Chinese with the help of Alexa or with the help of translator systems. Am I correct? So whatever I'm saying, so it will be real time, will be converted into Chinese or whatever languages, in reverse and vice versa also. Okay, now the one more question here is actually, so you are seeing that what is natural languages, or you know what is programming languages. The question is, what is the difference between natural language and programming language? This is an important thing. You know both. So you are dealing with both daily, I mean, not daily, okay, maybe the programming languages occasionally you will be dealing with. But what's the difference between the programming language and natural language? Participants?
Sir, natural language.
Yes, sir. Yeah,
sir,
please,
natural is unstructured, sir.
Okay, you mean to say the natural languages are unstructured.
Yes, sir.
Okay. Okay.
Programming languages are
well structured. Okay. The structure means
and the natural language have more ambiguity, sir.
Yeah. So the second point I agree with you, sir. Actually, natural languages are more ambiguity, but the structure wise, programming language is also in unstructured way. Natural language is also in unstructured way. Syntax is there in both. Programming language is also syntactically, if you are typing int and the next word should be the integer, if you are saying the next word should be a variable, int a. As a syntax, we are calling syntax. Natural language also have the syntax. If you are saying that beautiful, you are saying that the next word is definitely be a noun. You cannot add a beautiful played. The beautiful after the next word won't be a verb. Next word will be always be noun. Beautiful. If any adjective is there, the next word will be a noun. Any word, any articles, or we used to call it determiners. Here, this example itself, I'll take that once again. Pointer I'll take. If you see that any article is there, and the next word, any article here, there, an, or anything is the next word is also not be a noun. And the two word is there. So this is this two says about the infinite, and then the next word will be a noun. Sorry, next word will be a verb. To means to build, to play, to process. So these are all the language syntax. So both languages are having syntax, but what you said is exactly correct. The difference is ambiguity. So ambiguity is the main difference. And the next one we can see that emotions. So where natural language have emotions, and the programming languages we are not expressing emotions. And one more thing is natural languages having two forms. So you have a spoken form as well as a written form. So ambiguity is that you can write ambiguity, or you can tell also, you can say that ambiguity. So speech is there and text is there. Two forms. But programming languages, right now we have only text forms. Right now we are writing in TA only, but future there maybe we can expect that computers can communicate. Future robots can communicate in a programming language. So the future possibilities are there. Fine. So when you coming to the ambiguity, we'll see that what is meant by ambiguous. And so ambiguity is the main reason why the challenging part of natural language processing. Why not people are not getting good results in natural language processing system? See that Alexa is there. There are a lot of things we can do that. So there are model for Alexa Hindi, but I don't know how accurate it is. We don't have other language model for Alexa. Still, it's in a developing process. See that why Alexa? Why we should? Why English speaking people only can buy Alexa? Why not other language speaking guys? So they don't have model. They don't have accurate models. Have models? They don't have accurate models. That is the one thing. But future definitely will come. So Alexa in your local languages, you can choose the languages you want, and then you can talk to Alexa in your language. Alexa will answer in your language. Fine. So when you're coming to that ambiguity, so this is actually the problem in that natural language processing. One word or one sentence or one phrase have multiple meanings. But here in natural language processing, there are levels of ambiguities. First one is phonetic level ambiguity. Phonetic level means phonetic is a small unit of any language. Small unit means small meaningful unit. Say for example, how to pronounce this word? How to pronounce this word? Anyone, please? How to pronounce these words? Right. Right. So all three are same pronunciation. See that phonetically ambiguous. All three are same pronunciation, but spelling is different and meaning is also different. So this is a one level of ambiguity, phonetic level ambiguity. Lexical level ambiguity. So this is a word level. Lexicon means dictionary word level. So take a word and it have two different meanings. The two meanings because of its grammar categories, two different grammar categories. Book can be a noun and book can be a verb. So book noun means textbook. Book verb means book can be a verb, no? So first one is a textbook, other one is what spans? Book verb. You are saying about the ticket booking or talking about the reservation. So that time it's a book is a verb, whether you book the ticket or not. So that time it's a verb. So here this is a lexical level ambiguity. The lexical, you see that the lexical level ambiguity, the reason for the lexical level ambiguity is two different grammar categories. So I want an example for lexical ambiguity. I'll come back and I'll ask you people. And structural level ambiguity. I saw the man with the telescope. What are the two meanings for this sentence? I saw the man with the telescope. I saw the man using the telescope. That is one meaning. I saw the man with the telescope. I saw the man with the telescope. Two meanings. I saw the man who is holding the telescope. Correct? So this is structural level ambiguity. So the semantic level also, again, it's related to lexical level. So there is minute difference is the lexical level and semantic level. I'll explain. So semantic level also multiple meanings, but not different grammar categories. Same grammar category, multiple meanings. In lexical level ambiguity, we have seen that two meanings because of two grammar categories. One is a noun and other one may be a verb. In semantic level ambiguity, what we are saying is noun itself, there are two meanings. Noun one and the noun two, two meanings. Say for example, dish. Physical plate is also dish. Menu item also dish. Both are noun. Plant, biological plant or industrial plant. Bank, river bank also. So both are noun. Bank is a noun, river bank or financial bank. So now can you tell any example for this lexical level ambiguity and semantic level ambiguity? Wrong also, it's fine. Lexical level ambiguity and semantic level ambiguity. Next, we'll go to the applications. This is for making you to understand that the NLP and then the challenges in language processing. Participants, any answers? Lexical level ambiguity and the semantic level ambiguity. Examples. Book, I am saying that noun and verb. Any other word? It should say noun and verb.
Bat, sir.
Bat. Okay. Correct. My bat is comes in semantic level ambiguity or lexical level ambiguity?
Lexical.
So what are the two meanings you are saying, ma'am? Bat.
Like it is an animal and we make it as a thing, that is again noun. So
yeah.
batting, that becomes.
So bat is a specific word where both places you can keep. Lexical level ambiguity as well as semantic level ambiguity.
Okay,
lexical level ambiguity, batting also you will say the bat. Verb is there and noun also bat. And here bat two meanings. One is as you said that animal and then the other one is bat. Object.
Desert also we can say.
Yeah, exactly correct. Desert will comes in semantic level ambiguity.
Yes.
Yeah, thank you, ma'am. So this is the difference between the lexical level ambiguity and semantic level ambiguity. Both are deals with the words. Okay, both are deals with the words. Structural level ambiguity is a complete structure, and phonetic level ambiguity we have seen that. So these are the tasks making NLP complex. And a few examples for ambiguity we'll see that. So the one interesting sentence in the NLP, a famous sentence, I made her duck. There are 23 meanings for this sentence. 23 meanings for this sentence. Here I have listed five meanings. I made her duck. I cooked duck for her. I made her duck. Correct, no? I cooked duck for her. Oh, second meaning, you see that I cooked duck belonging to her. I made her duck. I cooked duck. I made her duck belonging to her. I created a toy duck which she wants. I made her duck. I only created her duck. Instead of that, I say I made her duck. I caused her to quickly lower her head or body. This is duck out. So for duck itself, we are saying that the noun itself there are multiple meanings, and this is a verb, duck out. I caused her to quickly lower her head or, but I made her duck. I used magic and turned her into duck. I made her duck. So see that 5 meanings. It's like the 23 meanings are there for this sentence. So the reason is actually the terms duck and hare and make, the multiple meanings for these words. Okay. The next, next example, the one. So you can see here, time flies like an arrow, fruit flies like a banana. What is the meaning for this sentence and what is ambiguity here? Time flies like an arrow, fruit flies like a banana. Meaning for this sentence and what is ambiguity here? Participants? Time flies like an arrow, fruit flies like a banana. It's wrong also fine, just a try.
Sir, it
Like
time
is moving fast.
Okay, moving. Okay, here, sir.
Comparing with another fruit, it is.
So here you mean to say that the fruit flies like an arrow, so it's an action verb. So this is a verb, correct, sir? Here.
Yes, sir.
Yeah, here what is it? Flies, sir. Fruit flies like a banana. Fruit flies.
Second one is two existing objects, and the first one just imagination, like.
Yeah, imagination. So here it says about the verb. Here is actually fruit flies like a banana. Fruit flies. So this is a noun. I'm talking about the insect. You understood? Fruit flies like a banana. So I'm talking about the insect. Fruit fly. So here in second case this is a noun. I hope it's clear. And the first case it is verb. Both are same spelling, same flies only. We saw her deck. We have seen this example. The mouse is on my desk. Whether I am saying about computer mouse or a real mouse. So Pawan Kumar saying that the rate of the fruit. Okay, the rate you are saying about the fruit flies like a banana. Okay, that is also one meaning. Fruit prices are okay, fine. That is also one meaning of one. Thanks for bringing that. Okay, the next meaning we have next sentence we have seen this. I saw the man with the binoculars. We have seen this. They are hunting dogs. What are the two meanings for this sentence? They are hunting dogs. Participants?
Some people are trying to hunt a dog. That is, they are hunting it.
Okay, ma'am.
In other way, we can say in adjective way, they are hunting the dogs.
The people itself, you are telling that. On other one is they are hunting that.
They are. We are pointing out somebody in saying in adjective way that they are hunting dogs.
Hunting dogs, yes. Another one is that's the normal sense. They are hunting dogs. Persons are they, and then their job is hunting dogs. The two meanings. Wanted, a nurse for a baby about 20 years old. What is ambiguous here? A nurse for a baby about 20 years old. So you are asking a nurse to be a 20 years or baby to be 20 years. So that is ambiguous here. Old men and women left the room. Old men and women left the room.
The old men and women left the room. That's
Yes.
one possibility. The old men, we can have a separation, that is the and as a compound one, and we can separate that too.
Whether the both are old or only men is old.
Such a.
Yeah. So the next one is that we have seen that same thing, like I saw the man, the lady hit the man with the number lock. The next one, I told her books were funny. Two meanings.
I told her books are funny, or I told her books
were funny. Yeah, exactly correct. The last one, Mary loves visiting relatives. What are the two meanings for the last one?
Mary loves visiting our relatives.
Yeah, Mary loves visiting, or whether the relatives are visiting or she is visiting.
Relatives.
Yeah, both meanings are there. No? Mary loves visiting relatives. She loves to visit relatives. Other one is she loves visiting relatives. So these are the things are making NLP complex one. These are the examples of ambiguous sentences. Now we'll go to the applications of the natural language processing. So this is the first one. I just to talk about the transfer learning. So I just go a little fast. So this is about the understanding language. See that the natural language, how the natural language is now recently the natural language processing direction is not only towards the grammar and other things. People may think that natural language processing means only the grammar like noun verb. So definitely not. Now the recent direction of the natural language processing is the research on the social media text. So where you don't require any linguistic information or linguistic knowledge. So only thing is you have to understand the problem statement and you have to find out the insight from the output. So see, for example, so this is a tweet. So says about literally your Facebook message app is useless. You only want it to increase profit. Please fix yourself. It's sad. So from this, what are the information I'm getting? I'm getting the emotion. So emotion is frustrated. He's using the term useless. So that guy is frustrated. The guy who posted this message. Tone, it's negative. So it's saying that useless word, it's subjective. Subject is there. Organization. So which organization I'm talking about? I'm talking about Facebook. Which product I'm talking about? Product is messenger app. See that I'm not just extracting that message app. So message app, you have mentioned is the message app, but the message app is messenger. So I should have knowledge to capture that map that. So the product is messenger app. So the adjective is useless and app. The English, we know that it's in the language is English. And I'm telling this is an informal. Can you help me to find out why I'm telling this informal? Why I'm telling this text is informal? Participants, any answers? Why I'm
Has
telling
it
this?
not been addressed to anybody, sir? Is that the case?
No, ma'am. It's a sad Facebook. This is a way of addressing, actually.
Addressing, yeah,
Yeah.
Facebook. Okay, got it.
Sir, I
Any
think
other
we don't
clues?
know.
Yes.
I don't know who text this or.
Yeah, but for the explanation purpose, we have taken that only that information. Whether we need to know that if you want to say that whether the text is formal or not, whether you need to see that who texted that. Any other clues in words? The word usage. It is not official. Fine. We cannot say that or not. Formal is there in a not official communication also.
Maybe we may not have any action or.
As informal, I'm saying I'm talking about that. I'm not saying informal means that the language is informal. English and language, the text is informal.
Okay, sir.
So you just find out the clues from the text. See the terms and find out.
It is like the usage of the word you, sir.
You here, this one you are saying, ma'am?
Yes.
Yeah. Upon
You
said
are
that.
above,
Yeah,
you are. That is again.
Yeah, this is the
literally you are.
Yeah, the main reason for saying the informal is that you are. So when you are going the two things when we are there dealing with the English, you are saying formal and informal based on that the abbreviation what you are using. This is your own abbreviation you are making. So we used to use in SMS and other messages that we are calling it as informal. So this is also other reason why NLP is complex and now. So what we have discussed all the things. Well, we haven't seen any informal text, but if you are opening the social media text or if any WhatsApp messages, definitely there will be a informal text will be there. So it makes NLP more challenging task. And how you are sending the good night to your friends nowadays. So earlier when I started using the mobile, I used to say that G capital I have to write good night. Now what is the things? How you are sending good night? See that if I ask here itself, I get the different variation. Pawan Kumar say that GD N8. And I'm saying that someone is studying some, same thing, Gokila. So I'm getting a message like GN. GN means also good night. So see that. So the earlier, the ambiguity, you see the problems, the interesting problem, when you say the term mouse, so the spelling is same. The ambiguous, I'm saying that two different meanings. Mouse, you are saying that whether it's a keyboard mouse or other thing. That is what the earlier challenges. But now, for single word, same word, multiple spellings, all are same. Good night. This is also good night. GN is also good night. Sponsor, right there, GD, and then N8 also good night. So see that. So the earlier challenge is 1:n. Am I correct? 1:n. One word, n meanings, or multiple meanings. That is ambiguity. Now the recent challenge after the social media text, we are having n:1. The n words are there, and then all the n words are representing only the one meaning. So we require a kind of normalization. So that is the other challenging task in natural language processing, particularly when you're dealing with the social media text. Fine. Okay, so these are some of the applications of NLP. I yesterday explained about the application in healthcare. So where the diagnosis report can be crawled and then it can be used for patient stratification. So stratification is nothing but you can see that the clustering. So based on the disease or based on the diagnosis, based on the region, I can categorize it. So there also you can use NLP. And these are the other NLP things. We have seen this yesterday, I explained that. So apart from this one, the NLP in healthcare, the recent one is actually to the mental health. I think I don't have a slide for that. So to predict the mental health of the person, by how he is talking and how he is messaging and how he is writing in exams. Using that, you can predict the mental, whether he is having any issues or not, whether he need record counseling or not, whether he is having any difficulties or not. So that is the other research is going on with respect to NLP. So NLP in education. So there are NLP in a lot of areas. No, I just taken a few areas, and then a few important areas are taken, like a health, education, academic, and then other things related to the current scenario. And then I just but NLP, there are a lot of other applications are there. So this is with respect to specific one, NLP in education. See that innovative education application you can make a language learning applications. So recently government introduced a app development challenge. So you can develop an app to how to learn a particular language. So educational chatbots, the doubts and whatever students are having, let them clear it using the chatbots. So other important thing. So when you are asking me as a teacher, so what is the difficult task for me? The most difficult task for me is not only for me, most of you guys also, correcting the answer sheets. I hope you'll agree with me. The second one is setting the question papers, that too the multiple choice questions. So these two are, I'll say that these two are the complicated task if I feel it's a teaching job. So in that case, so why don't you automate that? Why don't you automatically answer, or why don't you automatically grade the students' answers? So that is the interesting one. Actually, a lot of research are happening in this. So automatic essay and then answer grading in quality assessment. And the next one, as I said that, can you mute? Someone mic is on. Yeah, I think it's Bharati. Okay, fine. Okay, the next one is the automatic question, automatic exercise generation. So this is what, as I said, that the multiple choice question, not only multiple choice question, you can extract the true or false. You can form a true or false question from the class notes. You can form a match the correct answer or fill in the blanks automatically. That is also NLP application. So behavior analytics, as I said, that how the students the behavior. So how they are behaving, whether they will what kind of job they will get. We can analyze their answer script, and then we can analyze their activities, their mails, and then we can find out them. So this behavior analytics in industry, people are using this actually, the behavior analytics. The industry, particularly the mail, whatever mail you are sending to your subordinates and then your managers, everything will be recorded. From there, they can understand that your mental health. Whether you are suppose some they want to give you a higher position, so or they want you to lead to some project. So they have an option here to check your mental health, whether he is capable of doing that, whether he is having the aggressive nature or he is a very open type, or this kind of analysis they can do in a behavioral analytics. Or we can say that it's a personality prediction model. Fine. So the next thing is NLP in finance and agriculture. So when you say the finance, yeah, Vigneshwaran asked that for descriptive type answers, whether analysis is possible, your suggestions. Yeah, definitely, Vigneshwaran, things are possible actually. Even we are developing the small applications on that actually. As I said that I am bored with correcting the papers, because in our classes, 100 students will be there. So we are coming up, I'm just as I asked the students group to develop a project. We are just guiding them actually. We have started. So initially it's called it comes from the concept called semantic similarity. So I just type here actually semantic similarity. So even we have published a few papers on semantic similarity. So, my final objective is we should come up with this model for Indian languages. That is also important actually. So where you can see that we have a state board exams and other exams are there. The native languages also should have this kind of systems. So this comes under concept of semantic. Oh, so the similarity spelling is wrong actually. Yes,
Okay, sir. Okay,
yes,
sir.
yeah,
Understood.
similarity. Fine.
Thank you, sir.
So thank you. So NLP in finance and then agriculture, if you are seeing in the finance, the one thing is the stock market prediction. So there may be some news content. There may be some news says that Adani bought this particular company, or Adani sell the shares of this particular company. So that will affect the stock market. Definitely that will affect the stock market. So instead of only depending on the previous data of the stock market, but because time series analysis, the main problem in the time series analysis, it's try to fit some model. So when the major variation is there, it cannot predict. When the major variation is there, it cannot predict. And then the prediction will be based on not only this company, and then it's a group of companies, group of related companies. What about the companies related to oil? What about the companies related to electricity? So that kind of things is there. So that is a trend. If the oil prices, if some share of the oil company, prices or surge remains, all other companies also will follow the same way. So that is the thing. But definitely don't try that stock market. We can predict the stock market based on the previous data. And the other point is stock market of yesterday's data may help you. Last year data or even a week before data definitely won't help you. But rather than that, today's news content, today whatever it's happening, the news related to stock market or related to any oil or anything. So that news have the impact. Suppose government is changing changing one position, the financial, I'm saying the example, I'm saying that as changing the financial minister, that will affect or that will go in a positive direction of the stock prices. So news also have the ability to change the stock market. So that's what. So you can think about the sentiment analysis with the news as well with related to stock market prediction. So that is another interesting area of research. And chartboards for financial investment suggestions. We have chartboards, but not that accurate chartboards. We can build a chartboards even in local languages. How to build a chartboards to analyze the investment suggestions. Suppose I have this much money where I can invest, other things. So in chartboards for farmers. So it's again we are associated with agriculture in regional languages, and discovering crop disease trends using the farmer queries. So there are some systems, there are some platforms where farmer can ask a query, and then maybe the agriculture institutes or the experts in that area, the officers, they used to respond. So you can collect the queries, and then you can, from the queries, you can identify that is there any disease happening in this particular region. So if you're identifying that, yeah, there's some diseases, the disease I'm saying about the crop disease happening in this particular region, then you can take a alert, and then you can give a alert to the nearby regions. So you can give a precautions to the nearby regions. So based on that, farmer queries. So where you require the NLP analysis. Okay, so far we have seen about what is NLP, and then the applications, few applications of NLP. And now I'm going to that transfer learning. Before going to the transfer learning, so yesterday I explained about that the deep learning. So here the transfer learning concept in NLP, I want to say the transfer learning concept in NLP here. So when you have the documents and you have this is a deep learning model, you have a multiple hidden layers, so output units, and then this is the application you are developing. Fine. So we have in one good thing in image processing is we have a pixel. So pixel or the meaningful information of an image. So you can use, because machine learning or deep learning is a mathematical model. So you need to feed some numbers. It's a mathematics. You need to feed some numbers. You cannot feed a text, or you cannot feed an image, or you cannot feed a signal, and then you cannot ask a system to solve this equation or optimize this. You have to convert into meaningful numbers, and you have to pause it. So image, the good thing is it's already you can consider image as a matrix. So each pixel value having its meaningful numbers. So you can use it. Signal also having meaningful numbers. What about text? The text, we don't have a meaningful numbers. So the earlier models, they tried with the numbers like random initialization or representation. There are a lot of drawbacks in it. When you come into the deep learning, so we want some number, it should be meaningful number. So that number, how to generate the meaningful numbers? This is what called embeddings. Yesterday I answered the question also to someone. So this is called embeddings. It will convert the text documents. If you are passing to the embedding models, it will convert into meaningful numbers. Meaningful numbers for each word, not a single number. Each word can be represented into a vector. That's what we are calling it as a word to vec or doc to vec, or global is the other model, global vector. And now the recent models are called word. So this can be, this you can say that this model, whatever you have the meaningful, the vectors. So you can use a pre-trained model also. I'll say what is a pre-trained model example. Suppose you want to do the sentiment analysis. I hope you people are aware about a sentiment analysis. You want to do sentiment analysis. You have a documents of size only 5,000 documents. So you can use you cannot, if you instead of going for 5,000 documents to the embedding, you can use the pre-trained embedding of the existing pre-trained embedding. This is called this is used to call as a ImageNet moment of NLP. How ImageNet is popular in computer vision. So for any application, you can make use of ImageNet, and you can tune your tune the ImageNet model according to your application. Here also we're going to do the same, but here we have a pre-trained model. So I have only 5,000 data. So with the 5,000 data, I cannot get the meaningful vectors, but I have something called word-to-vec. The word-to-vec is trained on near 10 billion corpus, 10 billion sentences corpus. It's trained for the Google News corpus, and I have the vectors. Say that which one is powerful. If I go with 5,000, or that will be powerful, or this 10,000, 10 billion. 10 billion is definitely a powerful one. So what I can do is, I'm saying the example 10 billion. I don't know the exact number actually of the word-to-vec. What I'm going to do is, I'm making use of this word-to-vec vectors. What is this word-to-vec vectors? Each word will be there, and then the equivalent vectors will be there. Vectors means the numbers. So how I make use of that word numbers? So in your document, in your sentiment document, if any word is there, so you just refer the pre-trained model and take that vector and then replace it. That's it. Each and every word in your corpus should be replaced with the numbers, vectors. Then you are positive learning. So this is a called, this is called a transfer learning. One way you can say that it's a transfer learning. You have learned some knowledge. Pre-trained learning is you have learned the knowledge in a word-to-vec. Sorry, one second. Yeah, you have learned the knowledge. So that knowledge you are transferring to your application, sentiment analysis. Other guy, you want to do a translation. He can also use the same pre-trained model, and then he can do the translation. This is the one kind of transfer learning. I hope this is this is what we are going to see next. So how the transfer learning, what types of the transfer learning. The transfer learning is not only here. I'm talking about the NLP perspective. So the transfer learning, already, as I said, the computer is that you can try transfer learning in your domain. Say for if you are working in the informatics, if you are working any security system or credit card detection, IoT, you can take a transfer learning. I haven't seen any paper related to IoT with a transfer learning, or a smart grid with a transfer learning. So these things are the interesting research areas, upcoming research areas. So when you say the transfer learning, you see that what is meant transfer learning is, according to that definition, we can see that the ability of a system to recognize and apply knowledge and skills learned in previous tasks to new tasks, novel tasks. That's it. So you have the knowledge learned from the previous task. Why I should waste the knowledge? So that knowledge, 1 week or 10 days you trained and then you created the knowledge. A model you have created. It should not be only used for only one purpose. It should be used for multiple purpose. That is what the transfer learning, the objective of transfer learning. Say for example, you see that day-to-day life we are doing the transfer learning. We are telling something called prerequisites. No, in our teaching, we are saying the prerequisites. What is the prerequisites? So that is a transfer learning. It means that if you know the database, if you know the database systems, it's easy for you to learn the advanced database systems. You agree with me? Instead of teaching that advanced database to someone who doesn't know database system, it may be difficult. If a person knows C, you can easily teach a C++. Transfer learning. The knowledge, whatever he acquired in C, the knowledge, whatever he acquired in a database, he used in the learning that advanced database system. So the learning time will be less, and the learning process will be easier. He can easily map. Usually, how you will understand that? If you don't know something, if I'm saying that I'm talking about some object, say X, Y, Z, some object I'm telling them. You're telling that, sir, I don't know this object, how it will look like. I'm telling that this will be look like a car, and how you will imagine. So your imagination will be, okay, this is a X, Y, Z, Zosia will be look like a car. So now, so what I'm trying to do is actually, I'm teaching you this X, Y, Z was a there is nothing like that, but I'm teaching you with the existing knowledge, whatever you are having. Instead of saying that it's look like a car, I'm saying that it will have a wheels, it will have a doors, it will have a mirror. Like that, if I'm saying that, each one will think in a different ways. But if I say that if a car, it's a one entity, one big entity, I'm saying the car, you know already what is car. So with the knowledge, I can easily think, I can say that what is meant by X, Y, Z. I can say that, okay, you just to think a car, yes. So you see that 4 wheels are there in a car, no? Yes, 4 wheels are there. You just to remove the 4 wheels. And instead of down, you just to put that upside the wheel. So that is I'm saying the example actually. So that's the easy way to making you to understand a new things. Same thing we are going to do in a transfer learning. That concept is called transfer learning. If you understand this definition, then transfer learning is more. See that. If a person knows cycle, I'll say that example. If a person knows cycle, and then how you can easy for you to teach a two-wheeler. So he already know the balancing. He transfer the skills of the balancing. How much time it required to learn? If a person knows car, how much time it required for him to learn a lorry or other vehicles? So that is the same logic you're applying here. Chess with checkers. So both sides will be same. The coin place is different. You know how the movement is that you are telling. So chess, you know, means checkers is very easy. Or you see that if a person who doesn't know chess, you are teaching the checkers. That is difficult. Mathematics and computer science. I copied this slide actually from one. I'll have the reference at the end. But I don't want to delete this mathematics. They are relating mathematics and computer science. Do we really have that mathematics knowledge is required to learn computer science? That is a statement they have given. Do we really, our students are using the mathematics knowledge to learn the computer science? Or we are learning any computer science concept with the help of mathematics? That is a mistake what we're doing. So everywhere the mathematics is there. So try to add mathematics in everywhere. Fine. Table tennis and tennis, obviously. You know table tennis and the tennis is the same. This is called a transfer learning. So the types of transfer learning, if you see that, so why the transfer learning? Why I need to transfer the learning? So I can give you some examples. In some domains, the labeled data means when you're going for the supervised learning. So all over the world, if you have X, Y, you will get a better results rather than you have X. X is the input data, Y is labels, or only X. So in some domains, labeled data are short in supply. I said that in an example, I have a sentiment, I have only 5,000 data. 5,000 labeled data I have. So I cannot learn from the 5,000 data. So I can make use of other data. That is the thing, one thing. In some domain, the learning process is time consuming. If here we are talking about 5,000 data. So when you are talking about the huge data or the complex data, like graphs are there, you need to learn the networks. You need to learn the graphs out of it. So that the learning may be the time consuming. Instead of that, why don't I use the existing model as such? That's the one thing. So here the question says, how to extract knowledge learned from related domains to help learning in target domain. So is the one thing. So we used to say it's as a source domain. One is source domain, other one is a target domain. Source domain means whatever you have learned. Target domain means whatever you have mapped. That is a target domain. So here okay, I'll come to that. So language can be transferred. The language knowledge can be transferred. The language knowledge can be transferred. So people used to say that if you know Tamil, then it's easy to learn Malayalam. If you know how to read Telugu script, it's easy for you to read Kannada script. Script similarity is there. Tamil Malayalam language similarity itself is there. So that is a thing. That is called the transfer learning. We'll see that how the application we can make. So how to extract the knowledge learned from related documents to speed up the learning process. These two are we are going to answer that. So this is a slide says about transfer learning, also not a new concept. It's popular now. It's because of the deep learning models. So see that earlier, the traditional machine learning model. So you have a training data and then you have a test data in a sum. So say for example, an NLP example itself, I'll give the NLP example, training items. You have a Twitter data and then you are testing with the Twitter data. Fine, that is true. You have WhatsApp data. You are testing with the WhatsApp data. You have Facebook data used for training some sentiment analysis. You used the Facebook data for testing. But transfer learning across the domain, this is the one kind of transfer learning. With the help of Twitter data training, how can I get the good accuracy in WhatsApp data? The reason why I'm taking is, we cannot say that always you will get the label data for Twitter, label data for WhatsApp, label data for Facebook. Twitter data, fine, you can extract. Facebook data also can extract. WhatsApp data you cannot extract. But you want to develop a WhatsApp model. You have very small data. Only that data can be used for only testing. You cannot train the model. So this is the fact. So the model, whatever is you have in the Twitter and then Facebook can be, so you see here, Facebook trained data in a Facebook and you are tested with the WhatsApp. Reverse, WhatsApp trained data tested with the other things. So this is a one type of transfer learning. So transfer learning across domains. So other things also possible in the transfer learning. Suppose you have a 3 different tasks. So 3 different tasks you are having. See that 3 different tasks you are having, and you know that these 2 tasks are somehow similar tasks. And this is not a similar task. And this is one of the complicated tasks where you are getting accuracy, less accuracy. You'll get accuracy 80 here, you'll get 85 here, you are getting only 70 here. So the machine is not enough, or the algorithm is not, the data is not enough to learn. So what we can do is, we can club these 2 things to a similar task. We can make it as a source task. And that knowledge, whatever you gained in this, you can pass to the learning system of the 3rd model. So that definitely that will improve the system from 70 to 75. I'm saying approximately, it may lead to 80 also. See that transfer learning, if not from only one task, set of tasks also you can group together, you can pass the knowledge. So we have seen that how the things are passing. 2 things I need to answer that actually. The time, how we can say that the learning process is time consuming, and then the label data is short in supply. So as I said that here, the learning data is short in supply. Why? For 70% result, maybe because of my data set. So that I have recovered here. I used transfer learning approach. I used the huge data set of other 2 models. I improved. The next one is the time consuming. The transfer learning with the time consuming. You see that when you are talking about deep learning, definitely you know that it will take days to train. So we have a good number of public data set and feature learning happening, and then classified training. So some good institutions like the institutions who are having supercomputers. So, or they are doing this one. They are doing this, and then they are creating these features. Suppose I'm saying example. So a small institute cannot do this because they don't have the infrastructure, and then they cannot do that. But they can use the features as such. See that how it's a train time consuming. So your job is, you want to train for the small data set and take the small data, can transfer the features from here, and you can train your model. So as your data set size is very small, and you require only minutes to learn the model. You don't require because you are not learning, you are not taking the complete data set. Few data set may not be available also. You don't have a storage also to store few data set. But you can take the feature. The features mean just a parameters. Some meaningful parameters you can take, model you can append that model, and then you can go for the classified training. So this way the time consuming process. So it will be time efficient. The transfer learning will be, compared to the deep learning model, transfer learning will be, the training of the transfer learning will be in minutes. See the graph with respect to supervised learning and unsupervised learning and other things. So that is a usual. The commercial success is always will be the supervised learning. The supervised learning means you have a data points with labels. That's a supervised learning. And we know that the unsupervised learning and the reinforcement learning models are not far better. Particularly, I'm talking about the commercial success. When you want to build a system, definitely people will go for supervised learning models. Transfer learning is coming in between the unsupervised and then supervised learning, transfer learning. So even though you don't have a much supervised data, you can make use of the earlier learned values, and then you can build a transfer learning model.
Fine. This is what I used to say, the transfer learning with respect to CB. As I said that I'm not only touching NLP here, I'm talking the general guidelines for the transfer learning. The transfer learning had a high impact, as I said, that in the computer vision. So they are not bothered about the feature engineering. So we can see here, this is a one transfer learning concept called VGG16. People who work in the computer vision may know that this architecture. So if you're passing the input and then you get this output like that. So once the VGG is giving the output, whatever you have, the tune, whatever the vectors you receive from VGG, that can be fine tuned and then it can be used for your small number of examples. It's a transfer learning concept in computer vision. When you coming to that NLP, so there are a lot of, as I said, that there are a lot of transfer learning things are there actually. One is you can transfer the task. You can transfer the task. You can transfer the domain. Another thing it's not mentioned, you can transfer the languages. Okay, and so I'll say here actually, this is how the transfer learning explained here. You can see here, you can transfer the task. So I'll take two tasks, one is sentiment analysis, another one is a translation. The knowledge what you learn in the sentiment analysis can be transferred to learn the translation or improve the accuracy of the translation. This is the task transfer. Domain transfer. So we have seen the domain transfer. Sentiment analysis itself, there are 2-3 different domains are there. So one may be that, say for example, sentiment analysis for movie reviews and restaurant reviews, or you can say the product reviews. And so for India, suppose you want to build a sentiment analysis system for restaurant reviews. You don't have a much restaurant reviews in Indian context. So what you can do is you can take the restaurant reviews of other countries. You can make use of it, and then you can transfer that knowledge to build your transfer learning data. Transfer learning based system for identify the sentiment of the reviews in India, restaurant reviews. That is the one thing. Or you have a huge amount of movie reviews, Indian movie reviews data set, suppose. That knowledge you can transfer to the restaurant reviews. That is a other case. So task transfer, domain transfer. Other things, that's what here is that the transfer scenario says that different topics, different text type. So I explained the different text type, different topics. One may be the news domain. So if you can take the news domain data and then you can make use of how can you improve the news domain data to the academic data, academic research publications you are analyzing. So you can take the news domain data and then you can make use of here. So text type, the different type I explained, the different type of the text. Different languages, that's the other thing. Particularly similar languages. You have a system for Tamil translation. Using that knowledge, how can I build a translation system for Malayalam? Or how can I build a translation system for Telugu? So that is a knowledge, different language transfer. So one language you are building a system, you are using it for other language. So other one is unlabeled classes. So unlabeled classes is, so you have a data set for the sentiment. So the same example as I said, that the unbalanced classes. So the sentiment data set is for one class you have 1,000 reviews, and other 1,000 reviews are positive and only 50 reviews are negative. So high imbalanced classes. So for this imbalanced classes, how can you use the transfer learning? How can you convert that knowledge, whatever you learned in the source, to target? It's a totally different task. So this example, as I said, that sentiment analysis to translation. These are the transfer learning scenarios. So the training distribution, you can see here the different text type means newspaper text you can take. As you know that the newspaper content will be different from the social media content. It's a different accent and ages. So building a system with Alexa, the different accent. So different ages. So different topics and categories. So first says about the different topic. Second talks about different topics. How can I make use of, or how can I share the knowledge between it? It comes under transfer learning. So the current status of transfer learning with respect to NLP. So these models are not straightforward as computer vision. The reason is no universal deep feature in language processing. So this is the reason we are, I said no, that I'll go to the slide. This is the reason we are telling this embeddings. This is the reason we are using that embeddings here. So that's the embedding model. So I'll just take a 2 minutes break. I'll be back in 2 minutes. Okay, 1 second. Okay. Hello. Okay. Is it fine? I'm audible.
Yes, sir. Audible, sir.
Fine. So I'll continue that. Sorry. Okay. So this is the current status of transfer learning models with respect to language processing. So the thing is actually in computer vision we have the deep features are there. Actually, we don't have the deep universal features, but we have something called word embeddings. That's what, as I said, that we have something called a simple transfer through word embeddings can be possible now. So that is the current things. A lot of research is going on with respect to the transfer learning. NLP to come up with the deep features, but still all are depending on the word embedding models. So when you're going for the transfer, as I said that, so the task should be selected in such a way that, so as you can see here, how the post tagging can be leveraging NLP phenomenon, or how so the allied areas, if you're taking, suppose the sentiment is there, and there is something called a stance. So these two things you can put it together. You can see that how the sentiment analysis leveraging or influencing the stance. So that kind of research possibilities also there. So that is the current status of the transfer learning. Okay, and the recent one, the research is, as I said, that going on that universal deep features. So that there are a lot of new embedding models are coming actually now, started from BERT. So Google built the term BERT, actually BERT, bidirectional encoder decoder architecture. So this is a popular model of natural language processing, deep feature model. So there are a lot of variants of BERTs are available actually. So I'll just to show that what are the different BERT models are available. Okay, now when you are coming to that BERT embedding, so when you say the representations, as I said that, so representation plays a major role. The data you are representing, because you cannot feed the raw data to any machine learning model or deep learning model. So the representation, so image means the representation you can see here, the dense representation, you have a pixels. Each pixel having the meaningful. So this is the meaning. White means that there is a meaningful information. So red is it's a meaningful information. This is a red. So the system have meaningful information. So the spectrogram in audio signals also have the meaningful information. See that you can convert any signals to the audio spectrogram. So we have the meaningful information of high peaks and other things. When you come into the text, so the older representation is this one-not representation. So this would be a sparse representation. So, but here this is a dense and this is a dense representation, but this is sparse representation. That's what people move to that word embedding to get the dense representation. Dense, low dimensional, efficient representation. Low dimensional, efficient, dense representation, low efficient representation. Okay, the representation model is based on the statement given by the linguist Fur in 1957. Now we are building that. See that now we are building that model based on the statement given in 50 to 60 years back. So you shall know a word by the company it keeps. What does it mean? Quick answer from participant. You shall know a word by the company it keeps.
There's a context.
Yeah. So the single answer is a context. So you can understand the word by its context. Fine. Exactly correct. So you can see here, I have given some, I have blurred a word actually. Can you understand? Can you identify which word I have blurred here? Only one word I blurred in the complete picture actually. Which word I blurred? Can you identify? Can you find out?
I think first word is love.
Yeah, so all are same actually. So the answer is love. Yeah, correct. So how he identified that? How will you identify that? So he identified based on the
I love my mother.
Yeah, so it can be like no. But falling in like may not be appropriate. Am I correct? Love is the correct answer actually. So I'm saying that. So everywhere the word term is the love. So how he understands? So it's based on the context. You see here, calculate the chance on a successful relationship between the two people. So calculator. So which calculator? Love calculator. So the word is here. It's a word says the love. So
That's a blurred word actually. I mean, so this is the meaning of you shall know a word by the company or by the context. So I have given a context to you. You have identified the word. The same concept I'm going to use in a machine. What I'm going to do in the algorithm, I'm going to make an algorithm. So I'm going to hide one word to the algorithm, and I'm asking algorithm to learn its weight vectors until it identifies the word correctly. Fine. So that is that word embedding algorithm. I hope it's clear. So I'm going to use the same mechanism. I'm hiding that. I'm asking the system to learn the parameters weights. The weights are nothing but the word embedding matrix. Finally, weights is only the output. The weight only system is going to learn W optimum W. So while learning, initially I'm just going for random initialization. While learning, what it is doing is it's finding that it's finding that it's based on the real words. It's saying that if I give the same task to the system will say that, do you mean a word like? And I will say that, okay, first instead of saying like, system will say that, do you mean the word something? Do you mean the word break? Something it's asking break. So I'm saying that you are wrong. Instead of saying only wrong, I'm finding the error. Here the error is love minus break is the error. Love value or love vector minus break. The vector will be a huge actually because these two are different words. Next time the system is telling that, are you saying that like? Yeah, you are little close because like and love are, the error will be closer. That means that like and love are related. So like that, I'm tuning the parameters. This is called a parameter tuning. I'm tuning the parameters. Finally, I'm coming up with the optimum W. That W is called word embeddings. This is how it's working. As I said that this is the word embedding vector. This is a simple neural network architecture. You can see here input is there and hidden layer is there, output is there. And you are learning the hidden layer. The hidden layer is the size of the vectors, how much you want. So it means that the hidden layer says about in the word to vec, each word you are converting into vector. What size vector you want? The usual size for the word to converting is 100 and 300. This is the results for this is the n-dimensional vector. This number of neurons decide this whether it's 100 or 300. You can fix that. It's a hyperparameter. So you can fix the number of neurons. 100 neurons, if you are fixing, you will get a 100-dimension vector. It means that each word, suppose the word boy is there, means you will get a 100-dimension vector. Cat is there, means you'll get a 300-dimension or 300-dimension vector. This is the word-to-vec model. It's a transfer learning. How it's helped in the transfer learning, you see that? So the two things in the word-to-vec model, actually. So one is called SIBO model and other one is called skipgram model. SIBO model, skipgram model. SIBO means continuous bag of words model. Skipgram is skipgram. So it's skipping something. You see that. I'll take a sentence. Any sentence I'll take that. Suppose calculated. I'll just take any one sentence. I'll take here. I'm writing a sentence like I saw. Yeah. Yeah. 1 second. I saw a cat in my kitchen. Some I'm saying, some word I'm saying, kitchen, something. Okay. So how the system is learning, how it's identifying the vectors, how it's doing the operations, the SIBO and then skipgram. If this is a sentence, you are pausing. So please remember, in the word-to-vec modeling, we are giving only sentences we are giving as input. System, we are making a system to learn the vectors from the sentences. So here, I'm taking here my window size I have taken as a 5. So 5 words I'm taking. First 5 words I'm taking. So in that, WT-2 is I saw. The middle word I'm removing. I'm just hiding the middle word. Yeah. Cat. Yeah. This is SIBO model. So left 2 words, right 2 words I'm giving to the model. I'm asking the model to predict that A. Here W is there. Initially you are going with the random W. First sentence you are taken and then you are You are tuning the W and then you let it fit for this A. First, maybe system will say that whether the word is there. If the system says that the word is the, means you are finding the error. Error is the minus A. Because this is the predicted one. This is the actual one what you are having. This is the error. That error, using that error, you are tuning this W. Tuning this W means W new equal to old W plus or minus. You may have a learning rate and you have that the loss function. So dou L or error function, I can say that dou E with respect to what you are changing with respect to that parameters. What are the parameters you are executing? So this is simple neural network, how that backpropagation work, how you are updating the weights. Same way you are updating this W. So until you get A, once you get the way, you stop. First you are moving to the next sentence, not next sentence, next 5 words. Saw a cat in my next 5 words. I am forming this. Saw a cat will come here in my. So this is called SIBO. Here the SIBO, the input is context. You can see here the input is context. The output is word. Remember, input is a context and output is word. That is SIBO. Here in skipgram model, the same thing in a reverse way. Input is word. You are giving only word to the model. What you are expecting is context. You are expecting the neural network to learn the W. Here the W is there until it produces its context. Now that the next question you have to say that which model is efficient. 2 questions are there related to the model. So again, I'm repeating here the context is the input and word is the output. Here one word is the input. A is the input. You are making a system to predict that the left 2 words, right 2 words. That's a skipgram model. Now I have 2 questions. First question. So this example you have done, whether this is a SIBO model or skipgram model.
SIBO model.
SIBO model. Any other answers? Okay, so it's correct actually. So it's a SIBO model because context is given as input. I have given a context to you. I ask for a single word from you. Fine, that is a SIBO model. So skipgram model. Suppose the same experiment, the same thing what we have done, no? You identify the word love. No? Can we do in a reverse way, in a skipgram way? In the next slide, I'm going to give only the words love to you. Everywhere, wherever the word blood is, blood, no, the love, I just made it love and I'll give only that word to you. Is it possible for you to identify the remaining words?
No, sir. It's very tough.
Yeah. So that is SIBO. So which is toughest one is? SIBO model is the toughest one because so many words are there. So many other possibilities are there. You cannot easily find out that, but SIBO is the easy one. You have more words in your hand. You are going to find out a single word, but skipgram is different. But SIBO skipgram is the toughest one. Okay, now the next question is, which will be the efficient model? Which will be the efficient model? Whether a SIBO or skipgram?
I think SIBO only, sir.
Efficient model is SIBO. Any other answers? Which model is efficient, whether it's SIBO or skipgram? So, interestingly, SG is an efficient model compared to SIBO. I'll tell the reason. As I said that you are tuning this W. You are tuning this W parameters. One second. Going back. Yeah. You are tuning this W parameter. The finally your vector, no, this is your word vectors. This is the matrix you are getting. So in the context, in the SIBO model, how many times you need to edit this matrix? Maybe very few times. You can understand easily. Am I correct? Because you have a lot of other 4 words, you know, only 1 word to identify, you can finish it so. But in a reverse case, 1 word is there and then 4 words are given. You hided 4 words. As you said that it was time consuming, so that the algorithm is faster anyway. The algorithm will learn multiple times, it will update the W. The final W will be the optimum W, the skipgram W, whatever it's learned, that will be optimum W. So you said that it's allowed, but it doesn't mean that you know all these words. Am I correct? Sometimes you may not know any of the meaning of this words. I'm saying some example. You may not know the meaning of this words. Even though that you will find out this. But skipgram is not like that. Skipgram will each and every word it has to analyze, it has to find out. It has to find out the all semantic relationship of the word. So see, obviously the skipgram will produce efficient W compared to CBOOTH. Accuracy will be very not that much actually. If you are getting 90 here means you'll get 92 here. But you know that 2% is very important when you are reaching after 90. So that is called CBOOTH model and skipgram model. Fine, is it clear? Or this is a very important one. If you want to repeat, I'll repeat. Shall I continue?
So skipgram will be computationally intensive, no, sir, since it has to learn more.
Yes, computationally intensive, ma'am. But we have a good learning algorithms now. So now the learning doesn't matter actually. So that is, it's like a usual neural network learning. How much time the neural network learn to identify the parameters? Same time it will take. Because you see that, and one more point I want to say that yesterday I said why we are going for machine learning. So we cannot describe certain things and then we cannot do certain things in a known time. Okay, here you identified the word love within 3 seconds, or within say within 10 seconds you identify that's love. So it's easy for you. But when you are giving this task to the machine also will take it in an easy way. But when you are giving the tough task, the skipgram model, you said that it will take 2 days even for filling this one. No, so it will take 1 day to fill this one. So that is a challenging task for neural network because it's trying for nonlinear relationship between the semanticness of words. That's the power of neural networks. So you can find out. It shows the real power of the algorithm, skipgram model. Any other clarifications here?
The learning parameter. So first we are hiding 1 word and we are making the system to find it. So how many iteration of possible learning vectors we have to give? The one more is whether that should take the learning vector only from the machine.
Ma'am, your last thing I couldn't hear. Can you come back? Last sentence.
The learning vector, we have to pass the learning vector in a hidden layer, no, sir? So
yes. Hidden layer here in this word-to-vec model, the hidden layer is only, as I said, that this is a very shallow network. The hidden layer is only 1 layer.
Okay, so that is also from the same original sentence, or we have to pass it from some other samples?
The hidden layer you are saying. Hidden layer
Yes,
system is going to find out the hidden layer.
No, so what I want to have a clarity that it is going to have a trial. The first 5 words it is taking, the 1 word is hidden.
Yes.
So we have to give a system to learn from the sentence. So we have to pass to match with the vectors, whichever is the possibility. So first time when it is trying, will it going to take the same 5 characters? So sorry, 5 words, or some other set of 5 words to match with this?
Same 5 words it will take. It will learn from your corpus only.
Okay.
It always will learn from your corpus, because when it's depending on the other corpus, then it will be like a comparative.
Okay.
So it will learn from your corpus, or whatever sentences you are given in the corpus, it will try to learn. It will update this W. And as you said that sometimes you cannot reach the A. There may be possibilities you cannot reach. It's not you cannot reach the A. You will reach up to the nearby word. So that's what we are having something called a bias. So we can adjust that bias, because bias is also a learning parameter.
Okay, sir.
But we are not using bias in the pre-trained things. We are using only W.
Okay, sir. Okay,
I hope
sir.
it's clear now. Yeah.
Yes, yes, sir. Thank you.
You can see here the initial representation of the word will be like a one-not representation. So you are treating the word in the one-not representation. It means the one-not representation means, suppose the word cat is in the ith position in the vocabulary, only the ith position will be 1, all the remaining position will be 0. So this is a cat.
Okay.
The next word what you are predicting is like something like a dog, means dog is in the jth position. So somehow you have to tune this matrix and you have to get this vector. Final vector should be 0, 0, 0, 0, 1, 0, 0. But definitely it's not possible. So maybe you will get a vectors like a 0, 0.1, something like that, and yj will be the high. Okay, suppose you are using softmax, so there won't be any minus. So I'll just say only the probabilities. You'll get a values like a 0, 0.1, 0, 0, 0, and then the jth position you are getting 0.8, and somewhere you are getting 0.1. So this will be acceptable. System will consider that, okay, I have learned the error, the bias, it will consider that the bias is a 0.2 and minus 0.1 is the bias here, minus 0.2. So like that, it can stop the learning process.
Okay.
Once, if the W is not changing further, then it will stop the learning process, the usual neural network model.
Okay.
Any other clarification? Thank you, ma'am. Any other clarifications? Because there is this is an important one. The transfer learning of NLP model.
So can we combine SIBO and skipgram and use the learning done by SIBO?
Yeah, some of the researchers are trying that, ma'am, actually. So to combine the vectors, as you said that some of the research papers I have seen that 300 vectors taken from the SIBO and then 300 vectors from the skipgram model, and they have combined and then they have seen how that whether the accuracy is improving or not. That kind of research is also going on. And I have read somewhere actually after identifying SIBO and skipgram, they concordinate like this. Here one more learning they are doing. One more learning, there is kind of joint learning. So after finding this one more learning, second level of learning. The reason is, as I said, that this is shallow level network. We have only one hidden layers. So whatever information I missed here to learn, so people try to learn from the next layer. Like this. One more layer to concatenate these two things, and then they are getting the 300 vectors. Like you can pass this to the LSTM model or anything. Okay, so I'll continue. Some 2-3 slides are there, and then the BERT-ELMO, I think I require some 20 minutes. I'll cover this afternoon, 20 minutes. Then we'll go to the demo, the BERT-ELMO and then advanced BERT models. So 20 minutes or 30 minutes I require, I think. Fine. No problem. I'll just discuss the challenges now and then I'll stop now. Then we'll have a session afternoon. Fine. The challenges in word to vec. So one is actually the ambiguous words. Here it's a word model. I said about the word book is having 2 meanings. Word dish is having 2 meanings. So here in this word to vec, for both the dish, we'll have only 1 vectors. That is the main problem here. For both the dish, you have only 1 vectors. But the claim is the vector consists of the information of both dishes, whether the menu item or the physical plate. So that information is there in the vectors, that numbers, 300 or 100 numbers. So you can see here. So the sentences like this. So this is the ambiguity. You know already ambiguity, so I don't need to explain that. So Apple stock is rising. I don't want this Apple. So this is ambiguous word. Here the Apple says about the organization, and this is says about the fruit. So it's called a static embedding. So the Apple, regardless of the different context and the meanings, will have only 1 vectors. This is the first problem. And the second one is inability to handle the unknown words. So unknown words means you are trained with, as I said, that you have trained your model, pre-trained the model you are using. You are parsing your corpus. The word to vec is trained on Google News corpus. So in Google News, you may not find a word you are, sometime you are. You are passing a social media text. System will treat this you are is an unknown word or out of vocabulary word, and it will assign the random vector for this word. But this will reduce the accuracy of the model. This is the one problem in the word-to-vec. So what the solution they are giving is for the second model. You are taking the word-to-vec model, pre-trained model. So if this is trained on news corpus, the transfer learning is coming here. You see here, news corpus. But you want to apply this to the social media corpus. What they are telling is you tune this. It means that once again from this vector, you go once again training the word-to-vec vectors with the small corpus of social media. Now the vectors, whatever you are going to have, no, definitely you will have the word your will be there. So this will avoid the unknown words or out of vocabulary words. This is the other solution for that word-to-vec model. This model is 2013 model, actually 2013 model. Fine. So this one slide I'll stop, then we'll have a discussion. Any clarification, we'll see that. Okay. The third issue is actually no shared representation at subword levels. You see here, we have a word, suppose we have a word like, I'll take a morphology words, fine. Okay, simple word I'll take, no problem. Say, take the word ends. When you are dealing with this one, you have something called end is there already in your corpus, or end is there, your vector is there. So this system will treat this end and ends are two separate words. So this is the inflection, end, ends. So because of this one, so there are problems in the languages like Tamil or Malayalam or Telugu or Kannada, because we are morphologically rich languages. So we have a morphology, because one word play, if you are taking in Telugu equivalent play, you will get near 10,000 different forms for the word in Telugu. But English would get only 5 forms: play, playing, played, and all. But we have more than 10,000 forms. Tamil, we have 10,000 forms. So like that. So in that kind of words, we require a model to handle the subword levels, some character specific model. So that is missing in the word-to-vec model. So this is the challenges in the word-to-vec model. We'll see that how we can address the challenges of this word-to-vec model in afternoon, then followed by the demo of NLP. I will give the demo of NLP tools. First, I'll give the NLP tools demo, then I'll explain I'll take 1 or 2 codings, and then I'll explain it with how can you apply NLP for the deep learning. Fine. So now I am stopping here. Now it's 11:51. Now I'm stopping here. So if you have any questions or anything, you can ask. 10 minutes for discussion. So what we're going to see in afternoon is, first we'll see the advanced models. So the BORT and other things. The simple model. And how it's reach the accuracy, we'll see that how. Okay, fine. And recent embeddings. Yeah. Any questions? Participants, any queries? So organizers, if they don't have any questions, then
Sir, I have one question.
yeah, please, ma'am.
The word-to-vector, is it based on the POS tagging? Is there any relation between two?
No, ma'am. Word-to-vec is purely based on the sentences. We are only passing the sentences. So there are I am adding in my final slide, there are advanced models you can build on top of, I think, yeah, you can see here, annotated embedding, multilingual embedding, yeah, annotated embeddings. This is what I'm going to explain. Afternoon, I'll say that. So annotated embeddings is the new thing actually. You can post tag the words, then you can go for the annotation.
Okay.
You can go for embedding. So that time system will learn book different words, book, because when you're going for a part of speech tagging, book will be, noun will be there and verb will be there. System will understand the context and then it will learn in a different way.
So in what logic it is going to change that word into vectors, or if it does not depend on the POS?
That logic is simple neural network logic. Now, neural network, what we are doing, we are learning the vectors, no?
Okay.
So neural network, finally, yesterday I asked the question, what is the output of machine learning training?
Machine learning training output is weight. Am I correct?
Yes.
So finally what we are going to take is we are going to take this weight as a vector. The weight matrix size will be like a B cross N.
Okay.
V is your number of vocabularies and N is your how much neurons you are, I mean, whether you want a size 100 or 300. That is the N size. So actually,
so in the case of input, if I'm converting the input sentences into the vector,
okay,
in what basis it is going to take it as a zeros and ones?
Sentence you are
or
asking
some other
or
numbers?
Sentence or
the sentence. In the previous case, in the skipgram and all, we have used the word to vector conversion. No, the vector only passed as an input.
Yes, ma'am. Here one not representation.
Yes.
This one not representation you are asking, ma'am?
Yes, there is.
This can be anything, ma'am. Usually they will go with a like alphabetical order. They will go and then they will assign the values. This is the initial representation, but initially the size will be the V size. V means vocabulary. In a corpus, the vocabulary size may be the 50,000. That's what I said. It's a sparse representation.
Okay.
So that will be converted. But if you are seeing that we are not going to take the hidden values, the learned vector we are taking. That's what we are calling it as a representation.
Okay.
So this vector only we are treating. We are considering that as a word vectors.
Okay. Okay. Thank you.
Okay. So it's only training is there. Only word to word training. Only we are having a machine learning training.
Okay.
Any other questions or participants?
Sir, actually, SIBO model is for finding a word from existing sentences, right, sir?
Yeah, context.
Sir, context.
Yeah.
So the another model that is skipgram is
word only we are giving, and then we are finding the context. We are not, so that's what, as I said, that we are saying, I said that only training, we are not finding the word or we are not finding the context, because we know the word and then we know the context. Am I correct? You know the word, no? You know the word and the context. But using that known information, you are training the model and then you are tuning this W vector, W matrix.
Okay.
W is our final out.
Yes, sir. Now I got clarity.
Yeah.
Thank you, sir.
Thank you. No issues. Any other clarifications? Okay, fine. So no more questions mean then we'll start wind up the session and then I'll meet you people at 2 o'clock. Sir, organizers are you available?
Sir, yes, sir.
Yeah, yes, sir. So we'll start at 2 o'clock, sir.
Yes, sir. We'll start at 2 o'clock.
Okay. Thank you all. Thank you.
Thank you, sir. Thank you so much.
Thank you, sir.
Thank you, sir.
Yeah, thank you all.